In this video, I'd like to talk about extraneous solutions of radical equations. So equations involving square roots or cube roots or fourth roots and so on. And an extraneous solution is essentially a solution to an equation like this that does not actually satisfy the equation. And with these radical equations, it's always important to check your work to make sure that the solution or solutions that you got actually make sense when you plug them back in. So the real question becomes, why do we end up with these solutions that aren't actually solutions when we square both sides and then solve the resulting equation? And the main reason for this is that squaring or raising really to any even power on either side is not what we call a reversible operation. So, for instance, if we have, let's say that a is equal to b, then it is true that a squared would be equal to b squared. But if we reverse this and say that if a squared equals b squared, it's not always true that a would be equal to b. In fact, sometimes a will be equal to the opposite of b, since when you square a negative number, the negatives cancel out and it becomes positive. So squaring negative b, for instance, would still give you b squared. And we can consider a specific example. Let's say that the square root of x is equal to -1. And if we try to solve this equation, we'll square each side of this, and we get that x is equal to 1. But when x is equal to 1, if we plug that in, we get the square root of 1 is equal to -1. And this is obviously not true, since we're talking about the principal square root, which means we're looking for a positive solution. When you see this radical notation, assume that you're looking for the positive number that, when multiplied by itself, gives you whatever is on the inside. And so this isn't true. We ended up with a solution to this equation that didn't actually make sense. And so that's going to happen when you're raising each side to some even power, since this will also happen when raising to the fourth power, the sixth power, and so on. And it is mainly because of this property that when you raise a negative number to some even power, it becomes positive. And so, in some sense, information is lost. And another way to look at it, if we look at this specific example here, these extraneous solutions are going to be the solutions to the opposite of this left-hand side. So sometimes you will get that as your solution because when you square both sides here, you're still going to get whatever is underneath the radical. And so if there was a negative there, it goes away. Though keep in mind that if you have a equals b and you cube both sides or raise them to the fifth power or any odd power, then that is a reversible operation. You can start with a cubed equals b cubed, and it definitely is true that a would have to be equal to b, since raising a negative number to an odd power will give you a negative answer. But we'll come back to that in a later example. So let's, at this point, start going through the different example problems.